Hey, you know that little lump on your laptop charger? That little cylinder thing on your USB cable? I bet you've seen a million of them and never really given it a second thought. Well, today, that's going to change.
So what's it actually for? Is it just weird plastic? Maybe a weight to keep the cable from flying around? Nope, not at all. That little guy has a super important job, a protective one, and we're about to crack open the secret that's hiding inside your wires.
All right, so here it is. It's called a ferrite bead. You might also hear it called a ferrite choke. And yeah, it looks pretty basic, but trust me, it's a total unsung hero. It's a silent guardian fighting off a constant, invisible enemy that's trying to mess with our electronics.
So to really get what this little hero does, we first have to understand the villain it's up against. And that villain, well, engineers just call it noise.
Now, we're not talking about noise you can actually hear. This is electromagnetic interference, or EMI for short. The best way to think about it is like electrical static, just a bunch of high-frequency junk piggybacking on the real power and data that's flowing through your cables. And this invisible chaos, oh yeah, it can cause real problems, slowing things down, making your monitor flicker, or even crashing your device completely.
Okay, so where is all this garbage coming from? Well, here's the funny part. It's coming from inside the house. It's our own gadgets making it. Yep, the very things that make our tech so fast and powerful, the power supplies, the microprocessors, they just can't help but create this high-frequency mess as a side effect.
So if our own devices are creating the problem, how in the world do we stop them from messing with themselves and everything else? Well, this is where our little ferrite bead steps in. It's got a very specific and very cool superpower.
The job this bead has is actually really smart. It's gotta let the good stuff through, like the DC power that's charging your laptop. But it has to block all that bad high-frequency noise. Think of it like a bouncer at a nightclub for electrical signals. The good low-frequency power? Yep, come on in. But that high-frequency noise? Whoa, hold on, you're not on the list. You gotta go. And here's the really slick part, how it gets rid of that noise. See, it doesn't just block it and send it back where it came from. That could cause even more problems. Instead, the special material inside the bead literally absorbs the energy from that noise and turns it into heat. Just a tiny, tiny, harmless amount of heat. It basically eats the noise for lunch. Okay, now if you've dabbled in electronics, you might be sitting there thinking, aha, I know what this is. But hang on. This is where the story takes a turn, because this little bead is not what you think it is.
I mean, it blocks high frequencies, so it's got to be just a special kind of inductor, right? That's the logical leap. It looks like one, people talk about it like one, but that is not the whole picture. Not even close.
The truth of what's actually going on inside that little cylinder is way more complicated, and honestly, a lot more interesting. Get this, a ferrite bead is like a component with a split personality. In fact, it has 3 different personalities, and which one you get totally depends on the frequency of the signal going through it. Okay, let's break this down. At low frequencies, yeah, it acts like an inductor. Kind of boring and not very good at killing noise. But as the frequency climbs into that middle range, right where all the nasty EMI likes to hang out, it changes. It becomes resistive. This is its superpower. This is the sweet spot. It stops just storing energy and starts absorbing it, turning that noise into heat. Then, if the frequency gets too high, it changes again, becoming capacitive, and it loses its edge. So everything comes down to hitting that perfect resistive zone.
So this whole 3 personalities thing is super cool, right? But for an engineer, it's actually a huge headache, because you can't just slap any old bead on a cable. You have to pick the perfect champion for the job. Knowing its secret identity is really only half the battle. Choosing the right one is absolutely critical. Because if you pick a bead whose superpower zone doesn't line up with the exact frequency of the noise you're fighting, well, your filter might as well not even be there. It'll do absolutely nothing. So an engineer looks at a datasheet and they've got a checklist. Number 1, impedance at the frequency you care about. Basically, how strong is it? Number 2, max current. Can it handle the juice? But then there's a third thing, a hidden trap, something that can completely wreck the whole design. It's called DC bias. So what on earth is DC bias? Well, think about it. These things are on power cords, right? So there's a constant DC current flowing through them to power your device. The problem is that steady current actually messes with the ferrite bead. It saturates the material, and when that happens, its noise-fighting power just tanks.
And when I say tanks, I mean it. How much? It's kind of shocking.
that noise-killing power can drop by as much as 90%. 90! So that bead that looked amazing on the datasheet, in the real world it could be working at just 10% of its power. Ouch.
And this chart really lays it all out. The rookie mistake is just looking at that big, shiny impedance number on the front page of the datasheet. The pro move? You gotta dig for the chart that shows you what happens to that impedance with the DC current your circuit is actually using. That's the only number that matters. That's its true performance.
So that little lump on your cable, it's so much more than just a filter. It's this incredibly clever, dynamic component that's literally designed to eat electrical noise and turn it into heat. A tiny, unsung hero protecting all the tech we can't live without.
It's just an amazing example of how something that looks so simple can be hiding some seriously cool science. And it really makes you wonder, right? What other everyday parts are hiding these complex secret lives? Something to think about. Thanks for joining me for this one.